video, we are going to explain about automatic epilepsy detection using machine learning by naive-Bayes technique. Introduction. Epilepsy is a neurology disorder affecting about 50 million people in the world. EEG, which is electroencephalogram, is an effective and non-invasive technique commonly used for monitoring the brain activity and diagnosis of epilepsy. EEG readings are analyzed by neurologists to detect and categorize the patterns of the disease, such as pre-ictical spikes and seizures. The visual examination is time-consuming and laborious. It takes many hours to examine one-day data recording of a patient, and also it requires the service of an expert. As such, the analysis of recordings of patients put a heavy burden on neurologists and reduce their efficiency. Thus, limitations have motivated efforts to design and develop automated systems to assist the neurologist in classifying elliptic and non-elliptic EEG brain signals. Objective. The objective of this project is to utilize the naive-Bayes algorithm in detection of epilepsy disease by analyzing EEG data. The primary aim is to train the naive-Bayes model using the dataset and create a robust and accurate prediction tool for identifying with epilepsy disease. By leveraging machine learning techniques and naive-Bayes algorithm, the project seeks to develop a model that can analyze EEG data and classify the patients as either normal or suffering from the epilepsy disease. Requirements for the execution are hardware requirements and software requirements. Operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. Software requirements are Python IDEL of 3.7 version is required. Methodology. We have designed 5 modules for execution of the project. In first module, which is upload epilepsy dataset, here we will be uploading the dataset for application purpose. Next step is for dataset pre-processing. Dataset often contains missing values and non-numeric data such as patient ID, so we need to process the dataset to remove patient ID and missing values. Process data will be splitted into training and testing data, which is of 8:2 ratio. Next, train naive-Bayes algorithm. Process data will be input to the naive-Bayes algorithm to train the model. In the fourth module, which is epilepsy, predict epilepsy from test data. In this module, we will upload new test data and then apply train naive-Bayes model to predict whether the test data is normal or contains the epilepsy disease. In next module, which is last module, comparison. In this module, we will plot the naive-Bayes performance graph in the terms of precision, recall and accuracy and F1 score. To execute this project, first open the code folder. So this is the code folder. This file is the dataset file. This one is the main data. On this, we are going to build the algorithm. And on this dataset, we are going to test the algorithm. This is the main code file which contains the Python script in it. This is the run.bat file. Instead of executing the program in command line interface, we created a Windows bat file to execute the project. So double click on it to execute the project. This is the graphical user interface of this project. This is for interacting with the program. So first click on the upload epilepsy dataset to upload the dataset. Select this file and click it open. The dataset is uploaded, and here on x-axis we have the person, whether he have disease or whether he don't have a disease. 0 represents he don't have a disease and 1 represents he have a disease. On y-axis the count is mentioned. This is the bar of people having not disease, and this is the bar graph of people having disease. So this is the dataset. It contains the missing values and string values, so we need to pre-process it. Here the data is pre-processed. Now the data is split into train and test. 9200 records are for train and 2300 are for test. Now we are going to run the naive-Bayes algorithm. So click on the button train naive-Bayes algorithm. This is the confusion matrix of the naive-Bayes algorithm. Here are the accuracy, precision, recall, F measure scores for the naive-Bayes algorithm. Now we are going to predict the naive Bayes algorithm on test data. So to do that, click on the button Predict Epilepsy from Test Data. Here we need to select the test data. Click on Open. Here the dataset records are predicted. So for this record, it is predicted as normal, which means he doesn't have the disease. For second data, it is also predicted the same. For the third data, it is predicted that he has the epilepsy disease. Similarly, it will be continuing with all the records. Next, we are going to compare the graphs. So this is the comparison graph. Here on the x-axis, all the scores like type of metrics which are precision, recall, F-score and naive Bayes are mentioned. On Y-score, the values are mentioned. Conclusion. Based on the results obtained from the training, the naive Bayes algorithm, it achieved an accuracy of 5% in predicting epilepsy disease. The precision, recall, F1 score and accuracy metrics are analyzed to assess the performance of naive Bayes algorithm. High accuracy and the favorable values of precision, recall, F1 score and the accuracy suggest that the naive Bayes algorithm is proficient in predicting epilepsy disease based on the EEG data analysis. These results highlight the potential of naive Bayes algorithm as a reliable tool for early detection and diagnosis of epilepsy disease.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.